So in part A here, notice we have the same inequality as our previous example. Keep that in mind. The way we're going to do all these is by graphing the associated line. In this case, the associated line is 4x plus 3y equals 12. So to find the intercepts, which I again believe is the easiest way to do this, is that we put in numbers in for x and for y. The easiest number to pick is 0. So if we put in 0 in for y, that whole term goes away. Pretend it's not there. And you have 4x equals 12. Well, if 4x equals 12, that means x equals 3. So on the x-axis, we put a point at 3, 0. And now if we set x to be 0, then that whole term disappears, and you're left with 3y equals 12. Well, if 3y equals 12, then y equals 4. So on the y-axis, we put a point at 0, 4. Since there's an equal to sign here, we connect the dots. You should get used to labeling your equations. We'll need that soon. Okay, so now we pick a point, any point that's clearly not on this line. The most common point to pick is 0, 0. Notice for this line, 0, 0 is below the graph. So now we go back to what we did in our first couple examples. We're going to put in 0 in for x, 0 in for y, and we're going to determine if this is true or false. Notice 4 times 0 plus 3 times 0 is less than or equal to 12. So step 3 tells you how to shade. And that is 0, 0 is below the line. 0, 0 made it true. So we shade below the line. So remember, step 3 says I don't know why that back and forth is coming up. Step 3 says shade the true side. Hooray. If, for instance, we had picked 6, 6, just making that point up, notice 6, 6 is above the line. Well, if I put in 6 in for x and 6 in for y, it would have been false, which means all points above the line are false, which then means all points below the line are true. So again, step 3 says shade true. Do not look at the inequality, which is less than or equal to, and say, that says shade below. Nope, that's not going to work. Part B. So in part B, if we put in 0 in for y, that whole term disappears. And we have 5x equals 10, which means x is 2. If we put in 0 in for x, then that whole term disappears. And we have negative 2y equals 10. So y is negative 5. Remember, what I should do is I should have written this up here as an equation. So when you're graphing this line, you don't care what the inequality is. So don't think about, oh my gosh, I'm dividing by negative 2, I switched the sign. No, no, no. We're looking at the equation, actually. Oh, that's a 10, not a 0. Sorry about that. And that's an arrow, not a, I don't know what that was. Now it's better. But since our inequality, better arrow, has no equal sign when we connect these dots, we need a dotted line. Apparently I'm doing a dashed dotted line. That's fine too. Let's take that. There we go. Okay. Pick a point, any point that's clearly not on the line. If I picked 0, 0, 0, 0 is above the line. If I put in 0 in for x and 0 in for y, I get 0 is greater than 10. Well, 0 is not greater than 10 in most countries. 0, 0 is above the line. 0, 0 made it false. So where do I shade? I shade below the line. Again, no wimpy shading here. Great. Try some more. Now these next two are special cases. If you want, again, pause the video, try them on your own, and then when you're ready to go, replay the video. I'll just sit here and wait. You were supposed to hit pause. All right, welcome back from the pause. Good job, everyone. The next one is the line x equals 4. What type of line is this? Don't say straight. It's vertical. Yes, it's a vertical line. Since we have an equal sign here, we're going to use a solid line. Oh, geez. Oh, my gosh. Now, when you go ahead and pick your test point, don't freak out that there's no y in the inequality. It's going to be okay. Just pick any point you want. Let's make it exciting. Let's pick 2, 3. 2, 3 is to the left of the line. Since there's no y in the inequality, then I ignore the 3. I only care about the 2. Is this true or false? 2 greater than or equal to 4. That's totes false. Since the point in question, 2, 3, is to the left of the line, and it made it false, then I shade to the right of the line. Hooray. So again, don't be looking at the inequality to make an answer here. And lastly, 2x minus y equals 0. We're going to graph that one first. Well, the problem is if you go to try to find intercepts, you get the same point. You get 0, 0 for both of them. So because of that, pick a number, any other number, for x if you want, and then solve for y. So I'm going to pick x to be 2. If I picked x to be 2, and I solved for y, that's a y there, I promise, not a j. That's better. What do I get for y? I get 4. So that's the point 2, 4. So you could have picked any number you wanted, just not 0, because if you pick 0, you're going to get the point 0, 0 again. We don't want that. And it only takes 2 points to make a line. Since we have no equal sign, notice I'm using a dotted line there. Now when you go to pick your test point, you can't pick 0, 0 because this line goes through 0, 0, so pick any other point that's clearly not a line. So for instance, I'm going to pick 5, 1. Why? Because I said so. If I put in 5 in for x and 1 in for y, is this true or false? It's false. 9 is not less than 0. 5, 1 is below the line. 5, 1 made it false. So I shade above the line. Hooray. Now let's go back a couple. So back to these ordered pairs that we started the section with. 2, 1, negative 3, 4, 5, negative 1. And let's look at our first example here. 2, what do I have? 2, 1. Notice 2, 1 is this point right here. And let's see, what do we have? Oh, I went the wrong way. Negative 3, 4. Negative 3, 4 is this point right here. So notice the ones that say true are in the green region. But 5, negative 1, 5, negative 1, not in that green region. So this example with the 5 points is getting you ready for the graphing. But again, 3, 0 happens to be right on the line. There's no way to represent the answers except from a graph. You can't write all the points out because it's impossible. Because there's infinitely many points and you've got better things to do.